Oh, hey, what's up, guys? I was just working out because I'm in my gym. Yeah, 1,000, 1,001. Whew. What are you guys doing here? Oh, are you here for help with the math? Okay, so let's get into some math. Sorry that we're in my gym. It's just the only place I have a whiteboard at my house because I don't live at a school. So here we go. Here's my whiteboard. I got it all set up. Today we're working on 8-5, which you can see right here. Well, this one's kind of about triangles and circles moving stuff around. I'm just going to be bending over a lot trying to get into the camera and so you can see the work. So let's hop in. So basically what this is showing here is a number line. And this number line has a triangle underneath like a balance board. So imagine this like a seesaw. A seesaw, if it's too heavy on one side, will dip down or the other. So right now, what's up is that it's completely balanced. All three dots directly above it. What's up? Sorry, guys. I'm on Google Meet and people just keep popping in and saying, what's up? So if this was a 4 and all three were directly above it, it's completely balanced. It's not going to go to either side. But if I take one of these and I move it onto this side, there's 2 in the middle and 1 on that side. Which way is it going to dip? Now it's going to start dipping that way. And it's going to be at a slant like that. And that's not balanced. So what we're doing here is we're making it balanced. To make that happen, instead of taking 1 and moving it to the side, why don't you take 1 and move it all the way to the far side, and 1 more and move it all the way to the far side. Now you have an equal balance. This dot over here, this dot here, and 1 in the middle. It shows an empty number line on the side, so let's go ahead and move that because problem number 1 says move 1 dot to the left and 1 dot to the right so the balance point stays the same. If I want the balance point to stay at 4, I'm going to put 1 dot to the right. I'll put it all the way at the side, let's say at 7. That is 3 away from the original balance point. And then I need to go 3 to the other side to keep it balanced, which would be now I have it at 1, I have it at 7, and I'm going to keep that original dot at 4. So now it is completely balanced. This dot is the same distance away from the balance point as this dot is away from this one. So they are completely balanced. That's the answer to the very first problem. The second problem is very similar, except instead of being at 4, it's at a 9. So if you're going to move 2 dots, 1 to the left and 1 to the right, you leave 1 on the top, you move 1 however many away. You can move it 1 away, you can move it 2 away, you can move it 3 away, or you can move, and you have to move the other one the exact same way. It's kind of like algebra. So if I were going to do this same one, but not move it 3 spots away, but let's say I only moved it 2 spots away, that would be over the 2. I would leave my original dot, and then I would go 2 to this side. So the blue is balanced now. Does that make sense? You can't tell me if it does or not, but if it doesn't, just rewatch it a couple times. All right, let's move on to number 3 because that gets a little bit different. Now, number 3 is a bigger number line. It has a balance point on 16, has 3 dots over 12, and 3 dots over 20. And it asks you to move all of the dots so that there's a new balance point. Well, here's how you can find the balance point. This one is 1, 2, 3, 4 away from the balance point, and 1, 2, 3, 4 away from the balance point. So if I wanted to make it a different balance point, meaning I don't want the balance point here, let's say I want the balance point here. So I'm going to use blue to show that. Now my balance point will be at 15. Since my new balance point is going to be at 15, we need to move the dots closer or further away on how many sides. Let's make this easy on ourselves and only have to move 1. Let's keep these dots exactly where they are. These are 1, 2, 3 away from our balance point, which is 15. Let's move these ones to be 3 away also. 1, 2, 3. It'll move it all the way from 20 over here to 18. Same distance away from our balance points to the right and to the left. And now my new balance point is 15. That's how you can move a balance point. Quick tip, you could also not just have all three stacked on top of each other, but put one there and take one off this side and put it here. Now you have two dots that are 3 away from the balance point, two dots that are 3 away from the balance point, and one dot that is 2 away from the balance point, and one point that is one dot that is 2 away from the balance point. It's all about just making sure that you have like something that looks exactly the same on both sides. You need to keep your dots symmetrical and make sure that they are exactly the same number away from your balance point. That's if you wanted to move the balance point. Now, number 4 here says move all the dots so that the balance point is 6. If, I gotta find my eraser. Found it. If my number line goes from 1 to 12, and I'm looking at number 4, it wants me to move all of my dots to make sure the balance point is 6. I'm going to draw a triangle over 6. Now there should be 3 dots to the left and 3 dots to the right. The easiest one to do would just be put it one away. 3 dots over the 5 and 3 dots over the 7. That is 1 space to the right and 1 space to the left. It's exactly equal. And now my balance point's there. But I could be fancy with it. I could do it like this. See how it's the same pattern over here? There are 2 dots that are 1 away from the balance point and 1 dot that is 2 away from the balance point. I could even get super fancy and put them all spread out like this. It's a balanced graph at this point. It just looks different. It doesn't matter how you do it, just make sure it looks balanced. It's pretty simple. It's just making patterns. Now this is only 2 pages. It's asking you to predict the mean. So the mean is the hardest point to find. In fact, your mean is what we've been talking about the whole time. It's this average. So if my numbers are 10, 17, 9, 18, and 11, here's how I would find the mean. Mean, hardest one to find, you just add them all up. So 10, 17, 9, 18, and 11. That's 17 plus 9, or that's 7, plus 9 is 16, plus 8 becomes, that's a 9 and a 9, that's 18, plus 7, that's 25. Put the 5, carry the 2. 2, 3, 4, 5, 6, 65 altogether. So added up, their sum is 65. I need to take that 65 and I need to divide it by the quantity of data points I had, which was 1, 2, 3, 4, 5. 5 of those. Now, does 5 go into 6? Yes, 1 time. I can do that. And I can take away 5 and leave the 1, the 15. Does 5 go into 1? No. Does 5 go into 15? Yes, it goes in 3 times. Minus 15 leaves me an even number. I know that my mean is going to be 13. So I've done all that math, and then it wants me to graph it in like a area that looks similar to the backside. So here we go. My number line's here. I know that 13 is going to be my balance point. It goes from 8 to 18. And I'm going to put my triangle here. I'm going to put my dot over those numbers. So this would be at 9, 10, 11, 12. So there's 1 dot at 10. There's 1 dot at 17. There's 1 dot at 11. There's 1 dot at 9. 1, 2, 3, 4, 5. 1, 2, 3, 4. Missing my 18. Okay. And then you can just kind of determine where you think that balance point would be. So if there's 3 on this side and 2 on this side, your balance point is going to need to be closer to the 3 than it is to this side. We proved that it was 13 from our math, but if I were to just say, what's closer to these dots gathering, it's going to be that 13. So that's what it wants you to do here. It wants you to plot these points, and then you just have to figure out the mean. Now, the puzzle penguin, I'm not going to do on this. You just got to figure it out. It's not too hard. Just answer this question as best as you can. I don't care so much about this, but the rest I totally understand that you needed help with. So good luck today. Adios. I'm going to get back to my workout now. Bye.